Ma'am, we can't hear you. Ma'am is talking. I can't hear you.
नहीं आ रही आवाज
हाँ. मैं Participants, can you confirm if we are audible to you clearly? Okay, thank you.
Hello. Am I audible?
Perfectly fine.
Okay. That's at last.
Are we ready to start now?
So are you able to see my screen?
Yes, ma'am.
Yes,
Bit blurred.
Is my screen visible to you?
blur. It's blur.
Can you please stop sharing and then reshare?
I do not know unless I get the feedback. I do not know what is happening at your end.
No, it's okay. Ma'am, it's not, now it's okay. Yes, ma'am, it's okay.
Can anyone send me a message or something?
Ma'am is not.
Okay, so because for me, the screen is not visible, I'm actually going to look from my presentation and do it. So if there is anything wrong, please raise your hand or please send me a message. No, my screen is visible or not?
Visible now.
Is my screen visible? Can you please answer to this or not?
Yes, yes, it is visible.
It's visible, ma'am.
Okay. Sorry. So I'll continue. And okay. So I'll go to view. Uh, Just a minute, I'm actually making it full screen mode and okay, I don't know what's going wrong. Okay, so let me just zoom it from there. Okay. Full screen mode. Okay, fine. So today we are going to talk about explainable AI, what we mean by explainable AI and why it is needed, and what should we do to make our AI explainable. So generally, AI is a black box. Sorry, I'm really sorry. Okay. So why AI is a black box? Because if we look at, there's something wrong. Just a minute. Okay. Today's presentation is about explainable AI, and AI is a black box.
Hello.
Ma'am, you are audible. Now
No.
you are audible.
So we
Your
all know
voice is
that AI has come and it has entered many fields and it has started affecting our lives. And AI algorithms are becoming more and more powerful. They're able to ingest more data and give us more accurate predictions. Not necessarily always, but yes, they are there. And they are entering many sectors, especially healthcare, finance, legal, browser search. Even education is now being is now the prime target of AI, so that customized learning can be improved, learning can be in the native language. So AI is on the rise, and it is slowly and gradually becoming an integral component of our social and economic framework. But AI is a black box because we do not know why AI has given us a decision and how to interpret this decision. So most of the AI models are based on deep neural network, and they are like black boxes. What we mean by black box, we can see what input we have given, we can see what is the output, but we do not know, what is the internal decision making process. In some of the cases, even if we know the algorithm, we do not know how this algorithm, along with the neural network weights, has come to this particular decision. And that is where the problem lies. So we do not know whether AI decisions are correct or not. We need to understand it from this perspective, that AI is not always accurate. Even if the best models, they have an accuracy of even if they have an accuracy of 99.9, they are failing on 0.1%. And depending upon what kind of data they are handling, this 0.1% can become very, very important. For example, let's talk about COVID pandemic. If our best model were giving 99.9% accuracy on telling whether the COVID infection was true or was positive or not, whether the sample was COVID positive or not. So if it is failing on 0.1%, it means in a large population, many people will remain undetected, even if they are suffering from COVID, and some of the people will be misdiagnosed with COVID, though they are not suffering from it. Now, misdiagnosis can be ignored in some cases, but in not all the cases. So depending upon in which area AI is being applied, misdiagnosis or what we call false positive and false negative can have different significances. The problem with black box is that these boxes have been developed and now we are trying to make them explainable by trying to add something extra. But the problem is the decisions that they have made or that might impact life. It is actually impacting human life. So humans may or may not trust AI. So explainability is related to trustworthiness of AI systems. Now, we discussed it in the last class also, that establishing trust is the major challenge for AI at present. So why a particular decision was taken, how it was taken, especially when a medical diagnosis is underway or where a legal case is underway, then the implications become much important because it starts affecting human life. Similarly, for finances and cybersecurity, AI is being used to decide whether there is a fraud, whether there is a cyber attack. So now if AI gives us a decision and we do not know how this decision was arrived, we cannot improve the algorithm to prevent such frauds or attacks in future. Another problem is that we have seen that AI is data driven and data biases, developer biases, algorithmic biases, model biases become part of AI decision making process, and AI decision may be biased. So it can lead to unfair and discriminatory outcomes. Then the problem is accountability. If a decision goes wrong, if everything is fine, no one is going to bother. If something goes wrong, then who is going to take the responsibility? And that's where the problem comes, because this will have no legal implication also. So if, let's say, a self-driving car undergoes accident, who is responsible for this? AI, the person who developed the algorithm, the person who decided that this algorithm should be used in the car, or the person who was using the car. Now, this could be a very, very complex scenario, and that's why even though the self-driving cars are being tested, their commercial applicability in many scenarios is not possible, and its adaptation by user is also not possible. So unless it is proved that the algorithms which are used in a self-driving car are not going to pose any harm to the person who is inside the car, with very strong guarantees, this concept may not take up in many of the countries, especially where the traffic is heterogeneous. So there are regulatory hurdles also, like Europe has a very strong privacy rule. So AI systems are not supposed to reveal anything sensitive about a person to another person. But the problem is when AI is taking so much of the data in, we do not know how much data it is. How that data will become part of its own architecture, and when this data can be revealed. Another problem is that unlike another system where if machine goes wrong or if a software is not performing as per the requirement, there are fixes. People know why this is not working and they will make corrections and they will change. In case of a machinery, they will change it by a different part or they will redesign it. Similarly, for the software, they will identify what part is creating problem and they will rewrite it or make some changes to it. But problem in AI is we do not know why it is failing. Because the way AI algorithm works, it is a suboptimal algorithm it is not even guaranteed to give you an optimal result all the time. So you do not know whether this behavior is being manifested because of this, or there is an actual problem with the program. Of course, when we're talking about AI as a black box and other scenario, we ultimately have to come to the only solution that appears that is at present emerging is explainable AI. So we try to add explanation to the decisions. So AI should be able to explain its decision. So if it is able to explain its decision, then even if it's biased, the biases will become clearer to the people who are trying to read those decisions. And when we say explainability, it means that explainable has to be in a format which is understandable by human beings. This is an emerging field, and objective is that AI should be able to tell why a particular decision was taken, and it should be able to reason about this decision, create argument for that decision, and this should be in the human readable form. So there is no single method for adding explainability to AI. There are different mechanisms by which this can be done. We'll be going through that. Now, please note that in this particular presentation, XAI is actually an abbreviation of explainable AI. It has nothing to do with XAI, which is a AI company founded by Elon Musk. So now, point is, why should we adopt explainable AI? So, well, the user would like to know why a decision was taken, especially if the decision is against the user in some sense. For example, if someone is losing an insurance case and insurance claim is genuine, he would like to know why he is not getting the money. If someone has been diagnosed with a disease and the doctor says that AI is telling you to get an operation, the person should be able to know whether this operation is actually needed or not. So if there's an expensive treatment, people would try to avoid it if they cannot pay for it. But at that point, they need to know whether this is actually needed or not. So similarly, if a person is being arrested, he has a right to know why he or she is being arrested. So AI should be able to explain its decision. If it's not able to explain its decision, then it will be perceived as biased and not trustworthy. Though the decision may be right, but people still would not trust this system. Now, challenges are that sorry, my spelling is wrong. Challenges are that interpreting AI outcomes, especially when the decisions appear to be unfair or unreasonable, we do not know why they have crept in. Why AI is showing us this decision? Is it because of its decision making process, which has been influenced by the data? Is it something to do with the data? The data is biased, or it could be a software bug because of which the AI pipeline is not working correctly, or it may be the correct decision. So the problem is it is very difficult to identify or separate these cases from each other. Now, companies would like this much. That's why we need to create an explainable AI. The problem is that systems have been created, and the systems seem to work well in most of the cases. Of course, there are cases when they do not work well. So, at times, decision may be correct, but it may not be possible to explain it. And it happens with humans also. They make some decision on the basis of intuition, or on the basis of past experiences, or on the basis of some unknown fears, and they survive. But and another problem is that in case of AI, because the system have been built, now explainability is an afterthought. So now if you try to bring explainability to the system, it is going to, first of all, make the process longer, it will be delayed. And because explainability will require some analysis of how the deep learning different layers of deep learning network are creating output, it will delay, it will make it slower. And that could be one of the problems in deploying or bringing explainability to AI in very complex systems. What is explainable AI? Well, explainable AI, as we said earlier, that any AI system which can explain the reasoning behind its decision is an explainable AI, and purpose is to bring trustworthiness into the system and fairness into the system. So ethical AI, fairness AI, they all will require explainability to be part of AI system. Why does it matter? Well, we have already explained that it will build trust. People will think that AI system is not opaque, it is open, it is transparent. And somehow by using those decisions, somewhere we can also see who is accountable for making a incorrect why the decision, whether the decision was if the AI is not giving a good decision, then the person who is using that decision can actually change it. For example, if the AI shows that a patient is at a risk, but if the doctor analyzes by using other parameters that no patient is not at a risk, then doctor can always override AI decision, and hence ultimately the accountability would lie with the person who is going to use this system. And if the system is not used in judicious way, then that would be a problem. And when AI is used to discover new knowledge, for example, new proteins or new drugs, new molecules, or maybe theorem proof, then the way it has arrived at the decision can actually provide insights to the human experts, and they can also check whether yes, this particular decision is a correct decision or not. The way the arguments have been posed by AI can actually provide this kind of insight. Now we'll be talking about a very key difference: system interpretability and explainability, and how we'll be discussing it in the next few slides. Now, who are the stakeholders in XAI, explainable AI? For any AI system, the stakeholders will be the people who have developed it, people who are going to use it, people who are going to make some policy on the basis of this, and people who are going to regulate, see that the AI is conforming to the regulations and privacy framework of that particular country. So we have already discussed it. Now we'll talk about interpretability and explainability. Interpretability means, is the model interpretable? Do we know how this model is actually working? What kind of components are making this model? So this is actually telling about the transparency of the model, how the model is working. Explainability is, model may or may not be transparent, but if it is able to tell us whether this is how the decision was arrived at, then it's explainable. So we'll be taking a few examples in which we'll show that interpretability does not imply explainability, and explainability does not imply interpretability. So we'll be going for that. So this is again a tabular representation of the same idea, just to break the monotony of the presentation. So now let's consider a system, a model. This model is a kind of if-then rules for a medical diagnosis. If the patient was suffering for fever for so many days, if the temperature was above this threshold for all these days, if the person is having cough, then maybe it is this disease. Otherwise, we can go this disease. Now, let me tell you, I'm not a medical expert, and these rules are just for illustration purposes, and it is not an actual medical decision list. So it is not anything to do with medical. I'm not a medicine person. This is just for explaining what we mean by interpretability. So let's look at this rule. The model is interpretable because the logic is clear. We know how this model is working. This model is transparent. It is, first of all, checking the number of days. And if the number of days are above certain threshold, then it is checking the temperature. If it was above certain threshold, then it is actually taking some input on whether the cough is persistent or mild, and then accordingly it's giving some kind of output. So internal workings are not black box. We can see that if input is this, then output is going to be this. We can see how why the system is giving us this result. But the problem is it is not explainable. Now, why it is not explainable? Because we know how this model is working. We know that this model is taking temperature, comparing it with 100, but we do not know what was the criteria for setting the threshold to 100. On what basis the system arrived that we should check whether the temperature was above 100 or not. So let's say if a person was feverish for 2 days and then the temperature was above 102, then this model will not tell that the person still might be having the same symptoms or same disease, but this system will not be able to tell us. So the problem in this particular case is that this model does not indicate why the thresholds were chosen. Also, it doesn't offer whether there were other alternatives on the basis of which the decision could be made, and those were considered by the model and discarded in favor of this. So this model is interpretable but not explainable. Now, before I go for the next concept, where we say that this model can be explainable but not interpretable, let me just go through very briefly about what is a neural network. Now, most of you might be knowing it, and it is a very oversimplification of how our brain works. So generally we have some input, and these inputs are multiplied by some weights. Inputs are multiplied by some weights, and then they are summed together and pass through what we call a activation function, and this becomes, whatever is the outcome becomes the input for the next layer. So this indicates one layer, where one layer is receiving multiple input, and all these input are multiplied by the weight, summed, and become applied, some activation function applied, and become the output of the first neuron of the next layer. Now, so we'll see how it works. So this is, we are showing a single neuron, but in actual neural network, we have got multiple neurons. So input layer, each of them will receive one input, and then and this input will go to the sorry, this is the summation and the outcome of that summation, and then this is given to the as input to the next layer. Again, the next layer the next layer output will be they will be summed. Again, the output from will be summed, undergo the activation, and so on and so forth. So this is not a very complex architecture. But the problem with this architecture is that this has too many parameters. All these weights, what activation function is being applied, what bias is being what threshold is being used in this activation function, because activation function can check against the threshold and then can produce a result. They all become the parameter or parameters of this neural network. Okay. And so this is where the summation is taking place, and the activation function applied, and then this becomes input to the next layer. Similarly, here also we are applying the summation and activation function, and then input is applied to the next layer. So these all are indicating layer, input layer, and then output layer. So whatever is the outcome of the output layer becomes the output. So this is, we are not going to go through the mathematics of this. This is just an illustration. And why I'm illustrating it, to indicate that actually this model becomes very complex as we add number of layers. So let's say in this particular case, 1, 2, 3, 4, 5 input neurons, and again 1, 2, 3, 4, 5, again 5 input neuron. Each neuron is connected to the next neuron, so these are 25 connections. Again, these are 25 connections. These are 25 connections, and here it will be 15 connections. And each connection is having a weight. So you can see so many weights are there. And this is the very small neural network that I'm presenting. If we are talking about neural network which are dealing with images, and the size of images, let's say 10 into 10. So naturally, I need 100 neurons at this place to read each pixel. So 100 neurons, and if let's say here also I have got 20 neurons, so you can see 20 into 100, that is 2000 connections. So connection can be too many. So we are now going to check So if the model is complex, then it can be very difficult to comprehend the internal working of the model, because model is consisting of so many parts. The human brain cannot actually comprehend the model unless the model is presented in some statistical terms or average terms or something like that. So this is where you can see the number of connections start increasing, and deep neural network will have too many connections. Even each layer will have many neurons, many. So the input size will be very large, and then these connections will be very high. So it will be very complex architecture. When we talk about hyperparameters in case of a neural network, because this term will come at many places when you are dealing with models, they will talk about parameters and hyperparameters. So parameters are generally the so parameters are generally the connections. These connections mean the parameter. And hyperparameter would be how many layers are being used. Like in this particular case, I do not know, because this means there are the layers also. So how many layers are being used? How many neurons per layer? What is the activation function per layer? And what is the learning rate? They make and also the training related parameters, such as what kind of training is being used, mini batch training, and what is the batch size. They all are part of the hyperparameter. So now, if there is a deep learning network, why it will not be interpretable? It will not be interpretable because there are millions of weights and biases. So human mind cannot comprehend how these are connected together and how they are working together. So there is no simple transparent logic to explain how the input is related to output. So it looks like a black box with internal workings opaque to human. But why it can be explainable? It can be explainable. So let's say we have an image processing system, and this is actually trained on animal images. So now it has been shown many animal images. So it can identify, or it can try to pick some input. Some input will be more relevant to images related to cats than they will be relevant to images related to dogs. It could be the shape of the ear, the placement of the ear, the color of the eye. It could be the fur. So it could be the overall relationship between body uh, size and face size. There could be many parameters here. So if many different images are shown to the neural network, it will start interpreting it will start coming reassigning the weight to the different connection in such a manner that for images of cat, certain neurons will be more firing than the other neurons. So this is what it will try to identify, that this for this particular image, uh, these inputs were more relevant to the data for this class. So for cat, it is quite possible that placement of ear as compared to the placement of ear and the way the ears are size of the ear may be relevant in comparing with dogs. So model may tell that, okay, these features were considered while making this decision that this particular image is a cat. So it may be an explainable model, but it may not be an interpretable model. Now, just to get a view, now let me be, there's a word of caution. This particular data, I requested Gemini to create for to get this data for me. Now, because all these models are in public domain and there are model cards available for this on Hugging Face, so most probably this data is correct, but I have not checked it. But in any case, the purpose is not the data. The purpose is you can see that number of layers are actually very high. And if you look at the number of parameters, they are going towards billion. And now most probably they might be approaching trillion of parameters in case of GPT-5 or something like this. They might not make those details very public. And then if you look at the input size, the model at a given time is going to look at 8,192 token to make sense of what is the relationship between different words of the input. So as compared to human beings, this data is too large. When we are trying to talk to someone, we can still understand in a very very small context, but that is not possible for the large language model. They have to have very large. So if you look at this complexity, naturally a human brain cannot comprehend how this will be working. But yes, explainability can be added to this, and that's what is the crux of the matter. Okay. If there are any questions, I can take that. So now when we're talking about interpretability, so it can be applied to very simple models, which are actually piecewise linear or linear regression. We can do that. Okay. And but if the model is complex, then interpretability will be at law. It will be very difficult for us to make it interpretable. Then the focus in interpretability is that model's internal logic is known and model structure is also known. It's a kind of transparent box where you can see all the component, but the problem is you still might not know why the particular decision was arrived, how the particular decision was arrived at. But in case of explainability, it could be a complex model, but still, if it's able to explain its decisions, then it is explainable. And generally, in most of the cases, we go for techniques which are post hoc in the nature. We'll be talking about these techniques not in too much detail because I do not know how many you are actually from computer science or not. So I will not go through that. So we'll keep it general purpose in this particular talk. So we have talked about these principles. I think we discussed this last class also. Sorry, last lecture also. So transparency means we know that how the model is behaving. Accountability, we can check how this decision was arrived at and what was the reasoning behind that decision. Fairness, we do not want the outcome to be biased, and the outcome should be equitable, at least proportionate to the representation of each class in the data set. Even when the data is missing and there is some uncertainty, the system should remain reliable. It should not reveal the sensitive data of other users, and the decision should be, which is not necessary, but decision should be based on ethical values, that is, or compassion or empathy. So of the human species. For example, if AI gives a climate, AI says that it has solved the climate problem, but for that about 30% of the population has to be displaced, then this might not be a very good solution because it doesn't conform to the ethical scenario. So which 30% have to be displaced? Why they have to be displaced? So there will not be any logic behind that, and that could be the problem. That was a very artificial example, but yes, people have given this kind of scenario in which they have seen that, let's say, if the climate change model of AI tells that that so much the oxygen has to be reduced this much, or so it can keep on sucking up all the oxygen, and ultimately the human life survival would be at risk. Now, explainability can be generally the kind of explanations we are going to talk. They can be either local or they could be global. When we're talking about local, it means for a given input, for one single input, what features are more relevant. And when you are talking about global scenario, then we are actually not considering a single input. We are actually looking at the outcome of most of the input. So it is presenting a global view. The other one is presenting a local view. Generally, local explanations are focused on a single specific prediction. So if this input is given, if this image is given, why AI is saying that it's a cat image. Or if this particular diagnosis is shown, if this particular X-ray is shown, why the AI is saying that bone might be broken at this point. So this kind of explanation is specific to that particular image. But if you're talking about a lot of images, then we are going for the global explanation. So global explanation has to give the overall behavior of the model. So instead of showing one picture and then saying that it is going to be cat, it might say that my decision, whenever I'm shown an image, I say it is a cat based on this parameter. So that is global explanation. So one way to explain local explanation is counterfactual. What you mean by counterfactual is that, okay, what required to be changed if AI needs to change a decision. So let's say AI has taken a decision that based on the performance, the person would be graded 7 out of 10. Now, if let's say the person was more interested in why I couldn't get a 9 out of 10, so counterfactual explanation would be that AI will say that, okay, if this were there in your resume, then maybe you would have got 9 out of 10. Now, this is going to tell that person what he's missing, and he can actually then work hard in those fields where what were the limitations or the weaknesses of the resume, and can try to improve his knowledge and reapply. So it is giving an actionable insight to the user. So another could be like a person has applied for a loan and then his loan was refused. And then if AI is giving a counterfactual explanation that your loan application would have been approved if you were earning so much per month, and if you were having previous loan was less than this much. So now the person knows that if he needs to apply for this loan, what is required to be done at his end, or he can apply for a smaller loan. So counterfactuals are powerful because they tell actionable input to the user who are going to use the AI system. Now, rule-based explanation, they are again in the form of if-else construct, and they are easier to understand. And so naturally, if you are going to have an if-else construct, then it will look something like a tree. Okay. I'll take a tree from the. It will look something like this. If what is color? If the color is green, then you check for the size. If the size is big, then so it is basically a kind of tree for decision. It is a if else kind of rules for deciding whether the image is of which fruit. So if the color is green and the size is big, then it is a watermelon. If the color is should be okay, color is green but the size is medium, then it's an apple. If the color is green and the size is very small, then it is a grape. So this is, so in this case again it is kind of if else kind of loop. And so these rules give can add explainability. So why this particular choice was chosen? So in this particular case, if the answer, okay, I'll come back to that. Sorry. I'll come back to that figure again. Now, generally, in case of computer science, we call this a tree, and this is the root of the tree. So basically, it's an inverted tree if we compare it with the natural tree. This is the root of the tree, and these are the leaves, which are actually the decisions. So if the decision is banana, then we can trace the path from banana to the root to see why this particular decision was taken. So this decision was taken because the color was yellow and the shape was thin. And if this is a apple, again, so the size was small and color was red. But if it was a grape, the size was medium or size was small. I think this has interchanged. It should be small and it should be medium. The size was small and The taste was sour, so that's why it's a grape. If the taste was sweet, it is a cherry. So by just tracing the path from the decision to the root, we can see why this particular this is basically kind of explaining why this particular decision was made. So if as rule-based AI is explainable by default, and by just looking at and these rules can be expressed in form of a tree, and then tracing the path from leaf to the root is telling us how it is explainable. Now there is a problem with explainability also. Now what is the problem? Your models are not 100% accurate. If AI model is not 100% accurate, it means even if the explanation might be correct, for some cases it is failing and that explanation does not hold good. So people are trying to go for what we call causal AI, which is a kind of cause and effect relationship. So it is just telling that because if this is the cause, then effect is going to be this. So if the input is going to contain so in that particular case, spurious correlation that can manifest as false positive and false negative, that is actually not taken into consideration when we are taking this cause and effect relationship. But of course, these models are not that easy to build. So they are more trustworthy and they are more robust. So even if the data distribution changes, the cause and effect relationship will remain the same because this relationship has been derived from a lot of data. So if this was the cause, then the effect is going to be this. For example, if we say that if the river in the nature, cause and effect would be that if there is going to be increased rainfall, then the water table are going to rise, or the river table will rise, or the dam will be full, and then the dam gates have to be opened. And if that happens, then this area, the low area, might be submerged. So these are all cause and effect relationships. So if this happens, then this will happen. So causal AI will try to provide explanation in those forms. Okay, we have already talked about this. Sorry. So now we are talking about contrastive explanation. Contrastive explanation is trying to tell the decision in the form of, okay, for this particular case, the decision was yes. This was yes, but because for this case, it was no. So it is going to take two particular examples, two contrasting examples. One for which the decision was A, and another for which decision was not A, and then using that as and use that as an explanation. For example, in case of loan application, it could be that the loan was selected because the credit score was high, and for other applicants who had credit score less than this, the loan was not approved. So this kind of application provides a context and comparison point that makes reasoning more intuitive. And this is actually more close to how humans think, because we will think of why this particular decision and why not another different decision, why I have been failed and why he has not been failed. So this kind of so when this explanation comes why this particular decision has been taken and for you, and why this was not taken for the other person, people like to trust it more. People would know that system is not being biased against them, but it is using some rules to take that decision. Now, to improve explainability, not to improve explainability, in fact, we have to keep human in the loop in all AI systems. So here, human will be the ultimately decision-making entity. So AI will tell the outcome, and it might tell its decision as to it might tell the explanation or the arguments by which it arrived at that decision, but ultimately the user has to take his or her call to decide whether this decision is correct or not. So user should not be just a minute, I'll have to take this call. Okay, so what we need to do is we need to train the user that they should not trust AI blindly, and they should apply their own domain expertise or domain knowledge to judge whether AI is giving them correct decision or not. So AI should be perceived as an assistant who might not always be speaking truthfully, and and it should be treated more as a collaboration where AI is giving some output, but users should check whether this output is correct or not, and if it is not correct, then try to prompt AI to make it convey what was wrong with the AI decision, so that AI algorithms can be refined to create more accurate and valid outputs. So AI explanations can be used to validate whether that the reasoning is correct or not. It can be used to override, it can be used to refine, or it can be used to altogether reject the AI decision. So human in the loop collaboration can lead to AI with well-grounded decisions, because human is the domain expert and can lead to safer AI. So for example, if a radiologist is using an AI to detect tumor, AI can highlight which area, why AI thought that this tumor was a specific tumor, and can highlight those areas in the scan to tell the radiologist why it arrived at this decision. And now the radiologist can look at those areas more closely to see whether AI is making the correct call or not. Now, these are local explanation model, and they are model agnostic. But it doesn't matter whether you are using a transformer model or convolutional neural network model or long LSTM model. It is okay. You can use any model. They are not model dependent techniques. So LIME stands for local interpretable model agnostic explanation. So what actually it is trying to do is, it is a local explanation model. So it is going to give it for a specific input. So what it will do is, it will take the input and create some points which are similar to, create input which are similar to the given input. And for this set of input cluster, it will try to create a very small, simple model, and then try to identify what features are contributing for selection of what features were responsible for this particular specific input. For example, it might, if we're talking about cat and other animals images, so it can take the image of the cat, then it can change some of the pixels of that image, and that will create a new image of the cat, and then it can create such images, and then use a very simple model which will be based on linear regression to find out which features are actually more useful in identifying this as a cat. So then another one is shapely additive explanation. This is slightly more mathematically involved, because it is based on game theory, and it is assigning a shapely value to each feature. And this value is actually telling that if you are looking at all feature comps, so let's say there are three features, A, B, and C. So the combination could be that A can be relevant, B can be relevant, C can be relevant, or combination of A and B can be relevant, or A and C can be relevant, or combination of A, B, C can be relevant. So we have got all such combinations, which are right now 7 in this particular case. So this is actually going to tell whether the feature A was more, if I consider all the combination, what will be the contribution of feature A in each case, and try to take an average of this. So if I consider only A, the contribution of A would be so. So this is how it is going to derive this value, and I just. Now, decision tree is the simpler, again, something like if else scenario. It is now model specific, because it will now determine the threshold for each input feature which is relevant, and try to give a kind of tree. And by going through each node and comparing against the threshold, we can come across a decision. So there are inherently interpretable and they are transparent. So for example, this is a decision tree. Now, one of the decision tree was actually devised by Dr. Lee Goldman for medical diagnosis. So what was happening was that people complained of chest pain, and if the patient was elderly, the nursing staff decided or the doctor decided that he might be prone to heart attack, so they will hospitalize that person. But if the person was young, they will just check something and then send them back. But this was creating problem where the people who were actually going to, so some of the people who were discharged, they actually encountered heart attack and then they did not receive the medical attention in time. So Dr. Lee Goldman, he considered some parameter and created a decision tree. And then this decision tree actually helped the doctors decide whether the patient should be hospitalized, kept under observation, or should be sent back. And this method actually proved to be much better, as if in reducing the heart attack rate, in reducing the people who were in need of, in reducing the number of people who were sent home accurately and they actually needed medical help. In exercise, we will go through that. We'll try to see what his method was. Another is saliency map. Actually, this is a pictorial representation of which pixels of image or which segment of speech or which part of document are more relevant to the decision making process for a given scenario. So this is a kind of salience map which is actually constructed on the basis of illumination, color, etc. So the left hand side is the actual picture and this is the salience map. So it is not showing anything here much, but this was a public image, so I actually used this one. Again, attention is another mechanism by which they try to find out which, this is more towards language processing, so it is trying to find out what is the most relevant part of the input sequence while making a decision. So we'll try to do the same thing. We'll try to, today in the exercise, we'll first of all create longer sentences, complete sentences, and then try to miss some of the words and try to see whether the AI can still understand our query or not. This is some of the use cases of AI system. We have also discussed them in different form at different places. In healthcare, AI can create a saliency map to indicate why a tumor was considered malignant and why this malignant and what is the type of malignancy by highlighting the pixels so that the radiologist can also check and verify whether the decision made by AI is correct or not. In case of finance, AI can detect the fraud and highlight suspicious transaction across banks. So this is the transaction sequence which is suspicious. And now the finance investigator can check whether the AI has correctly identified the problem or it is a spurious match. In case of self-driving car, AI can create a log and at the same time logging the decision as to why the brakes were applied, why the car was accelerated, why the steering was moved to the left, why the steering was moved to the right, so that even if there's an accident, it can be checked whether the AI algorithm was driving the car correctly and trying to save the person or not. In case of cybersecurity, if there is an attack and if AI says that there is an attack, then it can give the reasoning of why it thought there was an attack. Then it can try to check that, okay, the system was trying to connect to your the malicious attack, the malicious request was trying to connect to your system, and it was actually originating from a suspicious URL. The packet was not correctly formatted, so it was trying to actually explore the vulnerability to enter the system. Similarly, in drug discovery, AI can highlight parts of the molecule which are and the shape of the structure to see why this could be an effective drug against certain diseases. But of course, it looks very good in theory, but actually applying explainability to practical system is still a challenge. If it were that easy, then people could have done it, isn't it? They would have added explainability to it. They wouldn't have tried to delay it or avoid it. Sometimes I think that it is the same situation as cybersecurity. The computers were made, internet was made, but no one thought of the security. Security came as an afterthought, so it is just like putting your patches to the quilt rather than making a quilt which was already resistant to winter or chill. So now, if the quilt is not effective, okay, add a patch at this point, add a patch at this point. AI should not become the same kind of future because we should learn from the technology that a technology which is incomplete in some sense is never going to be fully accepted. So there might not be option with us because AI is already there. But still, we might not be willing to apply AI at each and every aspect of our life if we are not trusting this technology. So what are the challenges? Challenges are, okay, deep models are very complex and they're hard to explain. Second thing is, if you're making an if AI is trying to explain the decision, whether this decision is meant for a expert or whether it is meant for a layperson. The problem is, yes, AI can give answer accordingly. If AI is giving answer to a doctor, it could be in medical terms, but if it is giving it to a patient, it might not be in the medical terms. It could be in the simple language, English or Hindi or whatever language the person understands. But now there is a problem. Are these two explanations equivalent? Do they imply the same thing? Will they be interpreted same way by both the experts and the layperson? So for medical terms, it might seem to the doctor that this situation, that this diagnosis, along with other lab tests or the chronic history of the patient's family, is putting him at a higher risk. But explanation to the patient might look that he's okay, and the doctor is unnecessarily suggesting a surgery. So problem is that if you try to customize explanation as per the level of the understanding of the person, there is a chance that there might be some loss of information. And different people that may not be on the same scale, on the same level when they are trying to interpret the information or decision, AI decision. So it can lead to misleading explanation if it tries to oversimplify it, and that is a problem. Now, point is that every day a new large language model is being uploaded, and it is more parameters, much larger than the previous model. Adding scalability to these models, which are becoming increasingly large in number of parameters and hyperparameters, is going to be a challenge. And then the problem is that data on which these models are being trained are different. So data itself could be, so the problem might not be with the AI decision, but the data on which it has been trained. Then most of the countries are coming up with various laws in respect of privacy, and Europe is already come with AI law also. So the AI has to comply with these rules. And the problem is that different countries might have different rule. And another thing is, can AI decision be used as a legal evidence? That could be another aspect. It will be difficult to support a decision which is, if it is based on statistics and probability, unless it is a very clear and made by a system which is not 100% accurate. So it could be another challenge. Now, humans should be able to understand the challenge, as we have said. Explanations for experts will be different from the end user. For example, if a complex mathematical formula is presented to doctor, he may not be interested in that. But a mathematician may not understand medical term, but may be more interested in the mathematical formula. The problem is that if the explanation is customized to the specific, if the explanation is customized, then different, again, there could be a loss of information because different people might interpret it differently. The main problem is that these methods are not deterministic, they are statistical or probability, so they might yield different explanation for the same input at different times. If the input is slightly changed, the explanation may completely change. So this could be a problem in making explainable AI. So challenges are consistency, cost. Of course, the cost is prohibitive. Now there is another challenge, which is data drift. Over the years, the data distributions change. For example, if you're talking about workforce, the number of women are changing, the number of people who are physically challenged are changing, the age distribution might change. So now, if AI had made a decision earlier, the same decision may not be applicable for this new data, and that could pose problem. So actually, if you look at the real world, it is dynamic. User behavior is changing, market trends are changing, the saving habits, food habits, they undergo change. So static explanation are not good enough. So explainable AI techniques will generate explanation as per instantaneous state of the model. What was the model state at that time? Generally, that state is when it was trained. Now, but when the new data come, periodically the model has to be retrained. The moment the model is retrained, the older explanation may not hold good for the in that context. And if that older explanation was used for some legal case, newer explanation is going to invalidate that. Then how do we deal with the legality of this? That would be part one. Part two, some of the people may believe that companies have on purpose applied that decision for them. AI decision was unfair to them. They might not know the intricacies of how the data has changed it, but they would like to believe that injustice was done to them. So when the data drift comes, it will lead to misleading explanation. Model will start making inaccurate prediction. It will create a disconnect between the explanation and the model's current behavior. So that would be a problem. So how do we deal with what would be the future explainable AI? That explainable AI has to be integral part of the complete AI pipeline. It cannot be added afterwards. It has to be part of the way you are designing your model, the way you are trying to train your data, how you are collecting your data. It should be part of that. So the complete pipeline should be thought of when you are thinking of explainability. Then ethics should be the fundamental building block if you want to go for responsible as well as so ethics should not be separate from explainability. It should also be part of explainability in the framework. There should be guidelines on what we mean by a good decision, good explanation, and the design should be human-centric. Now, compliance to regulation is again going to be challenged because different countries may have different laws. So what AI designer can do is they can customize model reason-wise, but the problem would be acceptability. If let's say Microsoft says that we have changed word software for India, and for Europe we are selling a different product, people might not like it. They might always feel that they are missing on something, so they are being charged the same. That could be a problem. So acceptability would be a problem the moment they are different models. And if the model explanations are customized regionally, then you're talking of a single model which is going to explain as per the constraint of that particular country or region. So it could be even challenging to build such model. So on the whole, adding so I'll stop at this note. On the whole, adding explainability to AI is challenging. But yes, a lot of work is being done, because ultimately, if we want a safer world, if we want a world which trusts machines and AI, explainability has to be part of AI. So if there are any questions, I'll take it. And any questions?
Thank you, ma'am. The questions are in chat. Like, the first question.
Yeah.
The
How-
first question is,
Okay, I'm going to read the question and then come to that, please. Okay. So how explainable AI handles inputs that are vague, unclear, or noisy and ambiguously defined. Explainable examples can maybe accidental car images. How would AI learn from such images without human intervention? Well, AI cannot learn everything which is vague and unclear and noisy. It can build probabilistic model from images that it has seen earlier and can try to make a decision and try to explain why that decision was made. But human intervention will make it interpret it in different way. For example, there was a case. It was a Tesla car. There was an accident on the road, and the vehicle was turned sideways. And the onboard system of the Tesla car could not detect that there was a vehicle which was lying there, and it was in self-driving mode, and it caused an accident. Because the data on which the Tesla car might have been trained was consisting of vehicle in upright position and not in the position on which it was actually on the ground. But if the driver were alert, it would have said that no, slow down, because there is a vehicle. I can see a vehicle lying on the road. So yes, the decision would have been improved and the car accident wouldn't have happened. So yes, AI cannot make decision in each and every scenario, but in certain scenarios, AI can handle uncertainty, but that is, it is handling it a different way. Let me tell you an example. For example, if in a chess game against a player, AI looking at the chessboard can see what could be the possible combination after this move. So after X moves, what could be the possible board positions, and which position is going to make me a winner and make other person a loser, and it will try to take the next step on the basis of this information. So as far, again, that information may not be complete at that time, because it might think of, let's say, 10 steps ahead or 20 steps ahead, or it can think of complete game also, but then it has to store too much memory. So in that case, because it is aware of the complete state space, it was able to take a decision. But in most of the cases, no, AI can fail spectacularly, if, at least on the data which it has not seen earlier. It can, yes. So that was the first question. Any other follow-up question from the person who asked it?
no, ma'am, I could get your point. Thank you so much.
Understand what I said?
Yes, ma'am. Yes, ma'am. My
What I'm saying
question
is that
yes, ma'am. Basically,
what I'm saying is that if the AI has not seen the data, it may not perform correctly. Sometimes it may seem to perform correctly because that data might be partially embedded in other images, but it may not, it is not guaranteed to work correctly if it has not seen the data earlier. So human intervention helps here, because human intervention can tell AI that this is the data. So when we are training the AI models for unforeseen situations, actually we are asking humans to annotate it and then making AI learn from it. So human is the very essential part of AI training. But seemingly, AI can make certain decisions when the data is not complete. It is the same situation like would do. When we're walking on the road in the night, we can still perceive whether someone is around us or not. So we are working on our intuition, on our knowledge of footsteps or the sounds, or we are somehow aware of our surroundings. we have that kind of so yes, so we also work on uncertain data, incomplete data. AI in some cases may be better than us, but in some cases it might be worse than us when it is dealing with uncertain data. So there is no single answer to this. AI can perform better in some cases. Yes, it can. In some cases, it can be completely. It can
Ma'am,
completely.
I think in the age of agentic AI, so how
Can you please
the
type, because I'm not able to understand what you're speaking. Can you type? That will be easier for me to understand.
yes.
Meanwhile, yes, adding explainability will bring the performance down. Performance in terms of time, the query will take longer time. It may not affect the accuracy of the system because system has already been trained on that. Or the problem could be that if you try to achieve too much accuracy, and if your explainable output becomes very cumbersome, that when these two input were there and then these four input were there, I made this decision. When these three input were, then it is quite possible then we may have to forego the accuracy also to make it more explainable. So yes, there is a trade-off. But it is not like if I increase the performance, it cannot be explainable. If I increase the explainability, the performance will always go down. So the trade-off is not that very clear. The problem is for very large systems, it is difficult for even humans to assess how good or how bad they are. So generally, let's talk about large language model like AI models that we have. They can, as I told you, they can have an input of 8,000. Now, if you look at all possible combinations of 8,000 sentences, a sentence consisting of 8,000 words, through the sentence can be larger than that. But let's say if we consider that, it will be too many combinations, and a single human cannot create all those combinations and feed to the AI system and then look at the output. So people have tried to analyze AI systems, but then they will be doing it with the data which is much less than what these what should be the actual data to test these machines. So that is another problem here. Okay, now can you come back to your question? So the problem is that okay, in case of agentic AI, we are assuming that agents are going to learn, but ultimately agent learning is also not going to be so agent is going to look at the environment and then trying to learn from that. So now if you're talking about car accident image, is that right? So if the agent has also the information that okay, this was what an accident looked like, then maybe agent can pick it up. But if that information is missing, then agent may not be able to learn that. Then again, a human intervention or human in the loop is required to make it learn. So some of the things agent can learn, some of the things agent may not be able to learn without human assistance. Is that okay? So when it comes to AI, the problem is that even the people who have designed AI, they are not able to explain why AI is performing good on some of the things and why it is failing spectacularly on the other scenarios. So it is the problem. Okay, another question. So I don't know whether I've satisfied you with my answer or not, but that is the situation with AI. So can we take a break for, when are we going to start again?
Ma'am, we can break for 10 minutes.
So let's have a break
Ma'am,
of, let's reassemble at 3 o'clock.
ma'am, a little more, I think 3:05 or 3:10 maybe.
Okay, so then make it 3:10.
Okay, ma'am. 3:10 is fine.
Okay,
Thank you.
see you then.